trig problems. As you can see from the other video, there are no trig examples, so I wanted to give you guys some trig examples here. And so we're going to work through all these problems. Make sure you add these to your notes. So we know that the antiderivative of cosine x is going to be sine x, and we're going to evaluate that from negative pi over 3 to positive pi over 3. And just as we saw before, we can plug in the upper bound, subtract from when we plug in the lower bound. Okay? The sine of pi over 3, using our knowledge of the unit circle, is going to be the square root of 3 over 2. And we're going to subtract that from whatever the sign is of negative pi over 3. Now remember, when you're going in the clockwise direction, you have your positive angles. So then when you're going in the the counterclockwise direction, you have your positive angles. When you go in the clockwise direction, you have your negative angles. So negative pi over 3 would be located here. And the value of that would be a negative square root of 3 over 2. Two negatives make a positive, so this becomes 2 square root of 3 over 2, which our answer would just be the square root of 3. For I, this is going to be negative 2 cosine x plus, this involves the linear factor, so special formulas that you guys are going to have to remember when it comes to doing integration. And so then it's going to be, sorry, not a plus, but a minus, because the antiderivative of sine is negative cosine. And this is going to be 1 over a cosine ax plus b, and we're going to evaluate that from 0 to pi. And again, we're going to plug in our upper bound, subtract from when we plug in our lower bound. And we want to make sure that we actually plug in 0, because as we know, sine and cosine of 0 actually sometimes can produce an actual answer. So we plug in our upper bound, subtract it from when we plug in our lower bound. So it's going to be cosine of 0 minus 1/2 cosine of 2 times 0, which is just 0 again. So the cosine of pi is negative 1. Negative 1 times negative 2 is positive 2. Then the cosine of 2 pi is 1. So then it's going to be minus 1/2. Minus, on inside of parentheses, the cosine of 0 is 1. So this becomes a negative 2. And then the cosine of 0 is 1. So this becomes a negative 1/2. Okay, if I distribute over the negative, that becomes 2 minus 1/2 plus 2 plus 1/2. So our answer here is going to be 4. All right, so for this one, this is another one of your special formulas. It's going to be 1 over a sine of ax plus b. So this is going to be 3 over 2, because again, 1 over 2/3 would give us 3 over 2. Sine of x, and we're going to evaluate that from 0 to pi over 2. So we're going to plug in pi over 2 and subtract when we plug in 0. The sine of pi over 2 is 1, so this becomes 3 over 2, minus the sine of 0, which is 0. So our answer is just, oh, I made a mistake. I wonder, did you guys catch it? What's my mistake? Hopefully you saw that I forgot to write in the actual linear factor, because it's 1 over a sine of ax plus b. I said it, but I didn't write it, so it's going to be 2/3 x that gets evaluated from pi over 2 to 0. So then when I plug it in, it's 3 over 2 sine of, this will turn into pi over 3 once I plug in pi over 2, and then minus 3 over 2 sine of, well, that still be 0. The sine of pi over 3 is the square root of 3 over 2. This becomes the square root of 3 square root of 3 over 4 minus 0. And so then our final answer just be 3 square root of 3 over 4. And then for this one, hopefully recognize that this is a u substitution problem where we can make u e to the x. So then du would be e to the x dx. So then this becomes the cosine of u du that we're going to evaluate with respective bounds. The antiderivative of cosine is sine. So this becomes sine of u that we're going to evaluate from ln pi over 4 to ln pi over 3. But instead of putting u, I'm going to go ahead and plug in that value, which was e to the x. So this becomes sine e to the ln pi over 4 minus, sorry, not pi over 4, pi over 3. minus sine e to the ln pi over 4. Of course, we know that e and ln cancel out, so this is really sine of pi over 3 minus the sine of pi over 4. The sine of pi over 3, as we know, is the square root of 3 over 2. The sine of pi over 4 is the square root of 2 over 2. So our answer is the square root of 3 minus the square root of 2 all over 2. And really what this is just more examples and more practice with the fundamental theorem of calculus, using some strict functions. And so hopefully you guys were able to follow along. Hopefully it makes sense. And you guys will have homework in regards to that.